Welcome to lesson 4.3, and in this section we'll be talking about multiplying and dividing monomials. So before we get started, I'll show you my one sheet and what I wrote down for section 4.3. It's taken right from page 147, gives examples of some monomials and also some examples of non-monomials. And my note there is basically if there's a plus or minus sign, it's not a monomial. It becomes a binomial or a trinomial or a polynomial. So also there is a product of powers property listed there on page 147 that says a to the m power times a to the n power equals a to the m plus n power. We're going to take a look at those by looking at some examples. So example 1 at the bottom of page 147 asks us to look at 5 squared times 5 to the third. Now if you just want to remember rules and say 2 plus 3 is 5, the answer is 5 to the 5th power. But it's just not some made up rule. It's because if you wrote out 2 5s, and you wrote out another 3 5s, there would be a total of 5 5s. So 1a, 5 to the 5th. 1b is 12 to the 3rd power times 12 to the negative 2 power. So 3 plus negative 2 is 1. Now let me just show you really quick why that is what it is. So I'm going to need some video skills here on how to make videos where you can see everything. So 12 to the 3rd power is 3 12s. So 12, 12, and 12. But if you remember from lesson 4.2, negative exponents move. And so what's going to happen to 12 to the negative 2? That's going to go to the denominator and become 12 to the positive 2. So we have 2 12s in the denominator. Well, what's 12 divided by 12? 1. 12 divided by 12, 1. There's 1 12 left, which is the answer, 12 to the 1st power. You also can get that answer by taking 3 plus negative 2 equals 1. But I did want to show you the reasoning behind that, just so you don't think that it's a bunch of rules to memorize. There is a reason for every rule in math, okay? So looking at example 2 now on page 148, it's asking you to, again, write using a positive exponent, but the only difference here is that you have variables instead of numbers here. So for 2a, we have y to the 6th times y to the 3rd, which is simply y to the 9th. Why? Because there's 6 y's and 3 more y's for a total of 9 y's, y to the 9th. Okay? 2b is r to the 6th times r to the negative 5th. So that's 6 plus negative 5, which is r to the 1st power, or just r, that's fine. But again, if I wrote out r, 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 I'm going to make a denominator here because r to the negative 5 is going to be r, 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 5 of them. Cancel them out. You have 1 r left, which is r to the 1st power. Okay? All right, 2c is a to the 7th times a to the 6th, which is a to the 13th. And for letter 2, or number 2d, don't let this one trick you, but x to the negative 6th times x to the 2 would be x to the negative 6 plus 2. Negative 6 plus 2 is negative 4. I'm not going to write it as x to the negative 4 because it says to express using a positive exponent. So in order to make that exponent positive, I have to move it. So the final answer for 2d is 1 over x to the 4th. Okay. For example 3, it's adding some coefficients. So that's just numbers in front of the variables. And because everything's being multiplied, you actually can multiply the coefficients, but then you add the exponents. And I know that seems silly when you're saying it, but hopefully I'm giving you lots of reasons and explanations as to why that works. So go ahead and read through examples A and B on your own, and then I'm going to jump down to 3A on page 149. 3A is 5A squared times negative 3A to the fourth. And what we're going to do is multiply the coefficients. So 5 times negative 3 is negative 15. There's 2 A's here and 4 A's there for a total of 6 A's. Common error would be to say, oh, 5 minus 3 is 2. And, oh, I'm multiplying, so this would be A to the 8th. Not the right answer. If I wrote this whole multiplication problem out, okay, I get 5A, negative 3, A. And I can regroup things because it's all being multiplied. Tell yourself what property that is. It allows you to move things around and not change the answer. We still get that negative 15a to the 6th if we write it out. It is kind of handy to remember the rules because if these powers are like 12 and 14, of course you don't want to write all those things out, but there is a reason for why you add the exponents and then you can multiply those coefficients. Okay, that's 3a. Why don't you go ahead and try 3b and then check to see if you have the same answer. You can hit pause if you need to. Okay, I'm going to multiply 6 times 2, which is 12. B to the negative 4th and B to the 2 is B to the negative 2. But it does say to write using positive exponents. So I'm going to drop this B to the negative 2 to the denominator and make it B to the positive 2. So the final answer for number 3B is 12 over B squared. Okay. For 3C, we have 6x cubed and we have negative 3x to the 5th. Okay, so 6 times negative 3 is negative 18. X to the 3rd, x to the 5th, that's a total of 8 x's. So your answer for 3C is negative 18 x to the 8th. And then go ahead and try 3D on your own. See what you get, and then we can compare answers. Hopefully you got 50n to the 9th. Okay? Just pay attention to negatives and again, take your time in remembering that when you're multiplying, you can add those exponents, but you can multiply the coefficients. That was example 3, and then we're moving on to quotient power properties. And so that is when you are dividing. And so I might take my one sheet right now and add that to my notes, that when you have a to the m divided by a to the n, you get a to the m minus n. So you're telling me that when I'm multiplying powers with the same base, when I multiply, I add the exponents, and when I divide powers with the same base, I subtract them. Yes, that's exactly what I'm saying. But again, I hope that you don't always think of it as a rule. I'm going to give you a reason why you subtract them, and we'll do some examples together. So on example 4, go ahead and read through those examples given in the textbook, and then we'll do the got it problems together. So 4a simply has 3 to the 9th power over 3 to the 2nd power. And all that really means is 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. In the denominator, 2 threes. Cross off the common ones because 3 divided by 3 is 1. 3 divided by 3 is 1. How many threes do we have left? Well, we have 7. So the answer is just 3 to the 7th power because 9 minus 2 is 7. That's the other thing you can try to do if you want to remember the rule that when you divide powers with the same base, you can subtract those exponents. Again, it's your preference on whether you want to remember rules or if you want to think about writing it out. For number 4b, you have b to the 7th over b to the 6th. So 4b, b to the 7th over b to the 6th. That's 1, 2, 3, 4, 5, 6, 7 b's over 1, 2, 3, 4, 5, 6. Cross off the common b's, and we have, oops, I think I got off there, 1b left. So the answer is just b for number 4b. And, 4c is a little tricky, okay? So 4c gives us 4 to the 5th power, and it's over 4 to the negative 2 power. So if you want to remember the rule, 5 minus a negative 2 becomes a positive 7. That's the answer. But another way to think of it is, remember we talked about negative exponents in section 4.2. In 4.2, we were often moving negative exponents to the denominator and making them positive, but negative exponents move and become positive. If they're already in the denominator, you want to move them to the numerator. And if those 4s, 4 to the negative 2, move to the numerator and I get 4 to the positive 2, I get the same answer, 4 to the 2, 4 squared, and 4 to the 5th is the same answer, 4 to the 7th. Okay, so let's see here, 4D. 4D is s to the negative 4th over s to the 1st power. Okay, s to the 1st power is just fine down here in the denominator hanging out. These 4, though, are going to join him down there because negative exponents move and become positive. So once those s's move down to the bottom and become positive, we have this one s and then 4 more that join. So we get s to the 5th on the bottom. Don't forget to put a 1 in the numerator. There's still something up there that has to be a placeholder, so the 1 has to be there. So for 4D, it's 1 over s to the 5th. Okay? I'm not going to go through the example on 5 just for time's sake, so hopefully those examples for 4.3 help you get started. And don't forget to practice iExcel and do your homework, check your answers, and email me, or make sure to ask me questions about anything that does not make sense. I can always think of another way to explain something to you or give you additional examples to show you why things work. I'm really passionate about making you understand why these things work instead of just memorizing a bunch of rules that you probably won't remember if you can't figure out the reasoning. So please ask, and I'm happy to help.